Good morning, students. In this section, we will discuss about Hay bridge. In our previous section, we have discussed regarding to Maxwell's bridge. This Hay bridge is used to determine the unknown value of inductance. Unknown value of inductance. And here, this Hay bridge is mainly used to measure inductance value, that is the quality factor q value is high. Q value is high. Such kind of coils, to measure such kind of coils, we are using here this Hay bridge. And simply it is the construction of Hay bridge. And just represent the arm names here. Just I'm assuming here it is point A, and it is B, it is C, and it is D. 4 points. And I'm assuming here it is the first arm. It is the first term. So I'm representing this one as C1, capacitor 1, capacitor in first term, resistor in first term. It is second term. So it is R2, resistor in second term. It is third arm, R3, and it is the unknown arm. So I'm representing here unknown value Rx, and it is inductor, so Lx, and it is source, voltage source V. And while coming to the construction point of view, between the terminals A and B, we're having series combination of C1 and R1. Between the terminals B and C, we're having resistor R2. Between the terminals A and D, we're having the resistance R3. Between the terminals C and D, we're having series combination of Rx, Lx. Between the terminals B and D, we're having source. Between the terminals A and C, we're having detector. It is the construction of this Hay bridge. Now we will find the inductance value by using this Hay bridge. Now coming to the circuit. From the circuit, from the bridge circuit, here it is the first term. So in the first term, we're having series combination of C1 R1. So I'm representing here simply Z1 equal to R1 minus J by omega C1. That is impedance of the first term. And similarly, the impedance of second arm, that is Z2 equal to, well, you're having the resistor R2. So Z2 equal to R2. And third arm, only resistor, Z3 equal to R3. Coming to the fourth arm, we're having series combination of Rx and Lx. So Zx or Z4, we can assume anyway. Zx equal to Rx plus j omega Lx. Rx plus j omega Lx. Here, these are the four impedances from the four arms. Now, in case of AC bridges, we have the balancing condition is the product of opposite arms is equal to the product of impedance product of other opposite arms. Here 2, 3 are opposite, 1, 4 are opposite. So simply I am writing here Z1 first arm into Zx equal to Z2 Z3 Z2 Z3. It is balancing condition. We have already derived the expression for balancing condition for AC bridges. Now I am substituting all these values in this equation. That means instead of Z1 I am substituting this value Z2 Z3 like that. So by substituting those values here, simply Z1 is nothing but R1 minus J by omega C1 into Zx is nothing but this one, Rx plus j omega Lx equal to Z2. Z2 is nothing but R2. Z3. Z3 is nothing but R3. This is the substitution. Now just simply simplifying. That means I'm multiplying here. So by multiplying, you get here R1 into Rx. That implies R1 Rx, and now this one into this one, that is plus j omega Lx R1 minus j Rx by omega C1, this one into this one, next this one into this one, minus into plus, minus j into j square omega Lx in the numerator by omega C1 equal to R2 R3, R2 R3. Now here j square is nothing but minus 1. J square is nothing but minus 1. Here it is the j square. It is nothing but minus 1. So minus 1 into 1 plus, and at the same time omega get cancelled. So R1 Rx plus j omega Lx R1 minus j Rx by omega C1 plus Lx by C1 equal to R2 R3, R2 R3. Now I'm taking this term, this term to this side. Here is minus. When it will becomes to this side, it will become plus. Then R1 Rx plus j omega Lx R1 plus Lx by C1 equal to R2 R3 plus j Rx by omega C1. Now compare real parts. Real parts comparison. Real parts are here, this one at LHS. This side is this one. So R1 Rx plus Rx by C1 equal to R2 R3. That is equation number 1. Now compare imaginary parts. Imaginary parts. Imaginary parts are this one, and this one. Those two are imaginary. So j omega Lx R1 equal to j Rx by omega C1. J will get cancelled. Then I'm getting here Rx equal to this, Rx equal to, I'm letting this term to this side. Rx equal to omega into omega square Lx R1 C1. Lx R1 C1. Now let it equation number 2. At the same time, substitute equation 2 in equation 1. Substitute equation 2 in equation 1. That means here Rx, this Rx has to be substitute here at this point. So we're getting here R1 is as usual R1 into Rx. Instead of Rx, just substitute this value, that is Rx into omega square Lx R1 C1 plus this one Lx by C1 equal to R2 R3, R2 R3. Now here, now C1, just doing here LCM with this C1. So R1 C1 into omega square Lx R1 C1 plus Lx whole divided by C1 equal to R2 R3. Now this C1 I am letting to this side. So r1 c1 omega square lx r1 c1 plus lx equal to r2 r3 c1 r2 r3 c1. And look at here, r1 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 square, c1 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 square. So lx omega square r1 square c1 square plus lx equal to r2 r3 c1. And I'm taking lx as a common term from these two. Lx into omega square r1 square c1 square plus 1 equal to r2 r3 c1. Just finally I'm writing here lx equal to r2 r3 c1 by 1 plus omega square r1 square c1 square. It is the expression for lx. Now substitute this lx in equation 2. To determine Rx, just substitute here. That means instead of this one, Lx, substitute that value. So we're getting here Rx equal to, we're getting here from equation 2, we have Rx equal to omega square Lx R1 C1. Omega square Lx R1 C1. That is equation 3. Equation 2, Rx equal to omega square Lx R1 C1. So come here. Then Rx equal to omega square Lx is nothing but this one, R2 R3 C1 by 1 plus omega square R1 square C1 square into R1 C1. Then we're getting here omega square C1 into C1, C1 square R2 R3 R1 by 1 plus omega square R1 square C1 square. It is the expression for Rx. Like this, by using Haybridge, we can find the value of inductance when the quality factor is greater than 10. And here we can also determine the quality factor Q. Q also determine. That is the simple formula for quality factor Q equal to omega Lx by Rx. That is the formula for quality factor Q. Here that is equal to omega into Lx value is this R2 R3 C1 by 1 plus omega square. So R2 R3 C1 by 1 plus omega square R1 square C1 square by Rx value is this. So omega square C1 square R2 R3 R1 by 1 plus omega square R1 square C1 square. Here these two will be get cancelled, and here R2 R2 R3 R3 C1 C1 omega omega. When it will becomes here, we're getting here omega C1 1. It is the quality factor for Haybridge.